Hey everyone, in this video we'll see how to detail a simple L block. So firstly I have opened this in a CATIA, so whichever the software may be, but the detailing standards will be same. So let's get started. I'll take a new default template. A3 size is fine for me. First I'll keep the front view. And go to this, turn on the hidden lines. Then I'll take the projected view. Hiding this one. And also I will keep a flame cut view for this one. First we need to see the 3D model that this L block is supposed to machine this side and this side. So both the sides it is machining. So we have to give extra stock on the machining side. I'll do, I'll, here I'll take the offset and I'll give 3 mm per side. Then I will delete these two lines and duplicate geometry these two lines and give a fillet of 3 mm because the flame cut profile will automatically generate a 3 mm radius. So we have to keep that in mind. 1 mm. Now, let's fix this construction what we have done just now. So now this is our flame cut profile. Means for manufacturing this L block, he will take this profile and load it in a machine, or whether he'll manually take a printout and do the cutout. Okay, so this profile, always remember this profile should always be in 1:1 scale. Don't reduce or increase the scale because this profile will be directly taken for the flame cut. Okay, and the thickness we should mention. Let me check the thickness. It's 20. should also mention the material. It varies from standards to standards, but this will be same. Now we'll copy this file. Here. Then change the line type, line size, and line type. Change it to phantom line and fix the construction. Okay. So now let's start the detailing, giving dimension. First, we'll start with the overall dimension, including the stock size. So length, width, and thickness. So we have given the overall dimension, and then next we'll move to the machining. So where the machining is happening, we should give that dimension. Okay. And also in some cases, even though we have given the flame cut profile, we should give the cutout dimension also. So cutout dimension is nothing but the dimension required to cut this profile. So so imagine this profile is not there. By taking these dimensions only, the manufacturer will cut this profile. So in some cases, even those are also required. So I'll explain that one also. So from here to here, I'll remove these edges because 23. Delete this construction line. Radius. Typical. Yeah. So now you can see, even if he has not considered this profile, by using these dimensions, including the radius, he can cut out this profile. Now let's move to machining. You give 20. So after cutting this profile, with reference to this edge, he is going to machine up to 20 mm. So remaining material will be removed. So that is the meaning of this dimension. So with reference to this edge, he's going to machine this one. Okay. Then we should give the machining symbol 1.6 or 3.2. So depends on the standard. So now this machining is finished. We should give the dimension for this machining. And with reference to this edge, we will be machine this one. And same machining symbol. So machining symbol should always be on that dimension where we have given the machining dimension. Okay. So now in this one, the machining is finished. Now let's move to the holes. So always remember the procedure will be like the first is the flame cut, second is machining, and third will be holes. Okay. First I need to fix the double hole. So these two are the double holes. So since I don't have the double symbol, so just assume these two are the double holes. Okay. Here these two are the double holes. So after machining, I should I should first fix the double hole. So these are all the free holes. I should not fix the free holes. So first from this machining, I'll fix this double hole. So one is X dimension, one is Y dimension. Now the hole is fixed. Either I can take this hole or from here to here, which one, anything is fine. So first I have taken this hole. Since it is from machining to the double, I'll give the tolerance of plus or minus O2. In case if there is a general tolerance stamp, no need to give this O2. So I'm just saying. And also from this dimension is from double to double. So I'll give plus or minus O2. Okay. So now this hole has been done, and with reference to this hole is been done. Now these holes need to be done. So from first double which we fixed, we should give this dimension 15, and then from this hole should give this one. So once after giving from this hole to this hole, again for this hole we should not take from this hole, because these two will be done at once. Okay. So once after doing this one, he'll take reference from here and do this hole. Okay. Now these four holes are done, but we should give the sizes of the hole. Double holes will always be H7. I'll give 2x. Just a moment. And these free holes. This one 2x. Okay. This cluster of holes are finished now. Then we should move to this one. Here also from this machine face, I'll fix this double hole. I'll give the tolerance, and then from this hole to this hole. And then from the first fixed double to from this hole to this hole. Okay. Since all this in same axis, so no need to give this 10 once again. You can just click this axis and hold control at this point. Just drag it. so that the manufacturer will understand the both the clusters are in same direction. Okay. Now let's give the whole dimension. For thread callout, I'll use this option. So now our L block is completely detailed. So let's check once again. This is the overall length, width, and the overall dimension is given. Then the machining dimension is given. The whole. Okay. So this is about the detailing of a simple L block. And in future videos, I'll be doing some more parts. So for more detailing videos, please follow the channel. Thank you.